Assalamualaikum warahmatullahi wabarakatuh. My name is NUR SYAHIRAH binti Amazlan. My number matric is B091810306. Okay, my supervisor for this BDP is Sheikh Ismail Fairuz bin Sheikh Zakaria. Okay, my title of this research is Study of Wear and Friction Performance of Low-Cost Commercial Engine Oil. Chapter 1. Engine oil is designed to lubricate the inner component of internal combustion engines, as well as to protect them against corrosion and keep them cool while in use. Lubrication is crucial in the manufacturing sector, where it is used extensively in shipping and all equipment. A lubricant is used to minimize friction between two moving surfaces or to prevent metal or metal touching. It may also increase the reliability of a machine or engine by protecting it from wear and corrosion, also extending its life. Wear occurs when two surfaces rub against one another, and more specifically when the surface is removed and deformed because of the rubbing motion. Fatigue, abrasive wear, adhesive wear, corrosion wear, the common type of wear that's seen in lubricated machinery. Wear may affect engine life. A greater wear rate implies a shorter engine life. The length of time an oil lasts is determined by its thickness or viscosity. Because a thick oil coating will have separated the rubbing components surface to minimize wear, it would have a significant economic effect. The viscosity of the oil is important when choosing a lubricant because the right lubricant will help to extend the life of the engine. The Society of Automotive Engineers, that is SAE, created a viscosity classification system to explain the kinematic viscosity of engine oil. It showed the temperature does have a significant impact on viscosity and oil film thickness. Okay, problem statement. Low quality oils contribute to higher fuel costs as well as engine works. If your vehicle's engine was damaged, non-compliant oil voids your warranty. Your warranty will be invalid if you use engine oil that does not meet the manufacturer's specification. Low-quality oils are hazardous to the atmosphere because they do not satisfy industry criteria established by regulatory agencies such as the ACEA and API, who oversee creating CO2 emission guidelines. Low-cost commercial engine oil lacks the wear and friction testing required. Research will discover what kind of engine oil have minimal friction and wear. Okay, research objective. First, the main objective of this study are, firstly, to study the performance of low-cost and branded commercial engine oil in terms of wear and friction. Second, to inspect the friction coefficient of low-cost and branded commercial engine oil. Third, to investigate the viscosity of low-cost and branded commercial engine oil. The analysis is scaled down to be more specific based on the following objective: to have a clear view of the main point. These following are the scope of this research. Firstly, the project is study on the performance of low-cost and branded commercial engine oil in terms of wear and friction. Second, the low-cost and branded commercial engine oil was used for this research. Third, the engine oil test was conducted by a 4-ball tester experimental. And lastly, the viscosity of the engine oil was measured by the viscometer test. Chapter 2. Type of oil. Firstly is mineral oil. Prior to development of synthetic oil, most car engines use mineral oil, which is derived from crude oil as a byproduct of the oil distillation process. Mineral oil is less expensive than a synthetic oil because it's easier to make, but it may not perform as well in a variety of situations. For example, the presence of wax in mineral oils can cause poor flow properties in cold weather, and poor oxidation stability at high temperature can result in sludge and acid buildup. Furthermore, mineral oil viscosity changes significantly with temperature, leading the base oil to thin significantly at temperatures. Okay, second is synthetic oil. Synthetic oils are chemically designed, so the oil molecules are more consistent in structure, have less contaminant, and have superior characteristics than mineral oil. Synthetic oil perform better at extreme of the temperature range, where hot or low, since they are designed with greater performance additive. Synthetic have a more homogeneous chemical structure than mineral oil, providing them greater heat stability. It also most costly than mineral oils due to their propensity to last longer. And lastly is semi-synthetic oil. Part of semi-synthetic oil is a mixture of mineral and synthetic oil designed to reduce cost while improving the viscosity and lubricating properties of mineral oil. They can also withstand heavy weight and severe temperatures. Blended oil evaporate less because of they are less volatile, resulting in greater fuel efficiency due to reduced oil loss. Although these oils are more expensive than conventional oil, they are less expensive than fully synthetic alternative. Oil standard. Okay, how to read engine oil. This value indicates how the oil flow at frigid temperatures. For example, SAE lubricating oil is 10W30. The number of the left of W, that is 10, refers to oil viscosity when temperatures are low. The lower the number, the better the flow will be. Okay, the number on the right is 30, and it varies depending on two factors, that is engine temperature and weather condition. When the engine temperature is high, this number refers to oil viscosity. The higher this value, the longer the lubricant will last when exposed to the heat of the engine's working temperature. Chapter 3, Methodology. Okay, for this research, we will use experiment for ball tester, that is to see the coefficient of friction and the scar diameter at the ball, and then to know the viscosity, we will use the heated viscometer. What mean of low cost oil? Okay, for this research, the low cost mean of the price of the engine oil that based on Shopee. So this is the price that I buy the engine oil. Okay, type of commercial low cost engine oil, that is Kumho engine oil, that is firstly the yellow is SAE 5W40 and the gray bottle is SAE 10W40. Okay, this is a type of branded engine oil, that is the gray one is Shell Helix 5W40 and the blue one is Shell Helix 10W40. Okay, this is the sample that used for this experimental that. Okay, next, this is the picture of that I conduct the experiment for viscometer test, and also this is the picture of when I conduct the 4-ball tester experimental. Okay, this table show the ASTM standard test method specification for 4-ball tested. Okay, 4-ball tested that I use for this experiment is D0918172, where that is for wear preventive characteristic of lubricating fluid. Okay, the speed that I use is 1200, and the load that used is 40 kg, and the duration of this experiment for one oil is around 60 minutes, and the temperature of oil is 75 degree. Chapter 4, Result and Discussion. Okay, this table is show the result that obtained from the experiment of viscometer test. Okay, from this table, the reading of kinematic viscosity at 40 degrees Celsius and 100 degrees Celsius was taken from the experimental, while the value of L and H is taken from the table of ASTM D2270 that use the value of kinematic viscosity at 100 degrees Celsius as shown in other slide. Okay, for the viscosity index is calculated by this formula, that is Vi equal to 100 times of VL minus VU divided by VL minus VH. Okay, this is the example of that viscosity index for 5W40. Okay, this picture is show the example of the reading that taken from ASTM D2270. Okay, for example, the reading of kinematic viscosity at 100 degrees Celsius, the value is 13.1, and the L you can take that is 235, while the H, the value of H is 122.9. Okay, this figure show the SAE viscosity grade for all type engine oils. In this experiment result, prove that the grade of oil that used in this in steel range, that is SAE 40. The kinematic viscosity at 100 degrees Celsius must around be at 12.5 until 60.3. Normally, application for this oil, that is SAE40, is for lubrication of gasoline engines for passengers car, commercial vehicle, and farm equipment. It also can be used for a hydraulic application. Okay, this is the classification of viscosity index. Okay, from the result that I get from this experimental is the Kumho oil 10W40 has a high viscosity index, while the others is very high, that is above from 110. Okay, the lowest value in this experimental is Kumho oil 10W40, that is 98.96. Okay, this table show the result of that obtained from experiment of 4-ball tester. Okay, the applied load, oil temperature, and speed is given on ASTM D4172. Okay, WSD is waste car diameter that appear in the ball. Okay, then the average will be calculated. Okay, at the end of this experiment, coefficient of friction is get to know the friction that appear in the oil. Okay, this is the approximate value of coefficient of friction based on the material section. Okay, in this experiment, the material of ball is steel. Okay, we can see that the material is steel on steel and under the lubricated. Okay, the good value of coefficient of friction is between 0.029 until 0.19. Okay, the result of this experiment showed all value of engine oil still in the range. The highest value of the COF is Shell oil KW40, and the lowest is Kumho oil 10W40. Okay, this picture show the graph of waste car diameter. Okay, for Kumho oil 5W40 is the highest waste car diameter that appear in the ball, that is 702. While next, the Kumho oil 10W40 is the lowest waste car diameter that appear, that is 409. Then the shell oil 5W40, the waste car diameter is 429, and lastly the shell oil 10W40 is 484. Okay, this is the graph of coefficient of friction versus time for Kumho and shell 5W40. Okay, as graph shown is the average of Kumho 5W40 is lowest than the shell oil 5W40. Okay, well, this is the graph of coefficient of friction versus time for Kumho and shell 10W40. Okay, this graph also show that the average of Kumho oil is lowest than the shell oil. Okay, this is the scar that appear on the surface ball after the 4-ball tester, and the average of this scar is 0.702. Okay, while this is for Kumho oil 10W40, the average of the waste scar diameter is 0.409, and this is for shell oil 5W40, that is the average is 0.429, and lastly this is the average of shell oil 10W40, that is 0.484. Conclusion: the viscosity test and the 4-ball test were performed in this research. Okay, the all that used for this experiment is Kumho 5W40, Kumho 10W40, shell 5W40, and shell 10W40. Okay, for the first and second objective, it was obtained by testing 4-ball test for wear and friction. Okay, lower wear scar means higher lubrication protection. This experiment employs ASTM D4172, that is for a preventive qualities of lubricating fluid test technique. Aside from that, the amount of weight and sliding speed may affect the ball's wear scar. Consequently, mechanical process may be optimized by maintaining sliding speed and normal load level. Lubrication reduce bearing wear, reduce friction between lubricated components, and prevents large build-up on interior surface. In short, lubricant decrease friction, allowing more works to be done, while possible increasing the life of moving equipment. The investigation was finished when the viscosity index was determined using the specified equation. Okay, high viscosity may cause poor oil flow, oil hanger, and dry start. Low viscosity increase the mechanical friction, resulting in heavier weight. It also may be worn due to the film loss. Using low viscosity oil in your engine will decrease energy loss, viscous drag, and improve overall vehicle economy, while also extending the drain interval. Low viscosity oil flow through the oil pump faster and use less energy to lubricate the engine. Low viscosity formula are also more eco-friendly. They reduce friction between the piston, compression ring, and the cylinder walls, that is for increasing the life of the engine component. Okay, as conclusion from all experiment, this table shown that the Kumho oil 10W40 is the good oil for use because it has low viscosity index and low wear scar diameter. Okay, for the COF reading, all the reading is in still range and good. Okay, this experiment proved that the low cost oil is not necessarily bad to use compared to shell oil 10W40. It has high value of viscosity index and high wear scar diameter. Okay, shall all 5W40 show the reading of viscosity index and wear scar diameter is lower than the Cumo all 5W40? Okay, this comparison indicate not all low-cost engine oil have good viscosity index and wear scar diameter reading. Recommendation. Okay, when the following improvements are recommended for comparable initiative in the future, the finding of this study may be more accurate when the experiment with several alternative oil and compare them to the used oil. Next, experiment using additive to observe how they impact the outcome. Next, take the oil reading when the oil is stable. Okay. Lastly, use scanning electron microscope, that is SEM, to see the resulting wear more clearly. Thank you.